All right, we're back, and we're going to talk about React, and we're going to talk about component state and lifecycle in this chapter. So the topics today are going to be following. It's going to be we're going to recap components from our previous lecture. We're going to talk about component state, and then we're going to go ahead and talk about lifecycle. So we're going to recap components. So basically, components are like functions. They have an input, props. Props is that famous props in React, which stands for properties. And we have state. When we start talking about props and state, they're very similar, but state can change, props cannot, right? And the output of these components is going to be an output to the UI. So their output typically is going to be that JSX syntax that we talked about, and that's going to control what the UI, what the user sees. So we want components to be reusable and composable. Composition, we want components that can be reused throughout our application. Something like a like button or a tweet button that can be used anywhere. We kind of want to build out our toolbox over time so that if we we have like a logging feature or something like that, we don't need to implement it on every time in different pages. We can have a common set of utility components that can be used anywhere, right? And when we're talking about components, just so React JSX knows what a component is, there's a special syntax here that is is this tag that actually needs to be camel cased here. So when we're talking about component, you need to actually camel case uh, the lead letter with a capitalization. Otherwise, React won't know what to do with it, right? If you have a button component that is all lowercase, it's going to get confused with the HTML element that's button. So if you're going to write a button component, you need to capitalize your function name. The first letter needs, so that when it actually renders, it'll know what to do with that. It'll translate it down to a component and treat it differently. So we can actually manage private state. Again, we'll get into the two different types, but there is a difference of stateless and stateful components and reactive updates. So React will react to the updates. So as this concept of state updates, React will be smart enough to re-render certain parts of the DOM tree based on state updates, and it's going to take those updates to the browser. Again, recapping what we talked about previously is that there is a concept of virtual view in memory. So what that is in React is it's called a virtual DOM. So it's basically like a mirror image of the DOM tree. And we already drew the DOM tree out previously, meaning that if you have a bunch of HTML tags in there, HTML, body, div, span, all these things, that gets translated into like an object tree if you can visualize that. And and basically React has a virtual memory of that so that it'll actually make the changes inside of that virtual tree and then apply those changes to the real DOM in real time without having to tear down that whole tree. It'll be smart enough to know that it needs to re-render certain aspects of that tree. If that makes any sense, it's not going to tear everything down. It's just going to update the nodes of the tree, and that's called tree reconciliation. So that React will be smart enough to reconcile the changes by diffing and update only the pieces of the tree or the nodes of the tree that need to be updated. So, so there are actually two types of components. There's the functional class components and functional components and class components. Basically, functional components are stateless typically, and class components have state. That has changed a little bit with the newer versions of React with hooks, but we'll get into that a little bit later. But for the very base starting points of components, it's a good idea to look at both of these and how they are different. And then when we move into hooks, you'll understand why you would need something like that. So the preference is to use a functional component over class because they're much simpler and there's a lot less code. However, class components are more powerful. They truly are. Um, but you can actually make functional components act like class components now if you have newer versions of React. So both return JSX, which is that syntactic sugar that is a mix of JavaScript and HTML. And so basically it looks like this. So here we have a constant function called intro that's using our ES6 syntax with the arrow function, and it returns this hi there wrapped in the paragraph tag. At the same time, we have this class component here that if you notice, it extends, that should actually be called intro, but it extends react.class as a base class. And because it extends from that parent class, a lot of methods come with it. So a render method is part of that. So it inherits the render method of its base class, which is react.component. There are a lot of other methods in there that we're going to talk about in a little bit, but just know that by inheriting from this base class, it gives your component a lot more power, I guess, that the functional component doesn't have, because the functional component at the end of the day is just a JavaScript function. That's all it is, right? And as you know, with a JavaScript function, it doesn't have much in its scope. By default, it doesn't really have much, right? It's up to you to implement all of that logic. So that's maybe why we would use class components over functional components. But if you wanted to do a very simple piece of UI, like display a button and some things like that in its display, always opt for functional components. They're very simple and they can be tested very easily. All right, so if we're talking about props and state, props, so both functional components and class components can use props as input, but props are immutable, meaning they're read-only and they cannot be changed, right? State is internal to a class component and is mutatable and can change. So if you think about it, a class component is just like a Java class. I mean, if you were to think about the concept of it and see in an object-oriented language like C# or Java, you have a concept of a class, and you can make an instance of a class, right? And then you have one instance in memory. You can derive multiple instances of that class. You can also do inheritance, inherit from a superclass, and you can get and override methods and all of these things, right? So it's a way of creating some type of inheritance and kind of these things, right? So basically, out of the box, you get a lot more. You get a lot more tools in the toolkit that you can use when you have that type of component. Sometimes there's too much in there, and there's a lot more code, like we said, and you'll see why. Like why you might opt to use like the very short syntax if you're just going to do a quick display, or you have something that is like a very small amount of JSX. Maybe you have a little tiny like button that does something very simple, or maybe you just have a title component that all it does is you pass in some props and it gives a name and a title. You may not want to go through all the hassle of creating a class component. You might just want to use a very simple, straightforward function component. That can be tested very easy. So state is really interesting because how React reflects changes in the DOM. When the state gets triggered, it re-triggers the render, and then there's all that tree reconciliation happening in the virtual DOM, and the DOM and it's smart enough to know what has changed and update that accordingly, right? So to recap, props are read-only. Props cannot be modified. Versus state. State changes can be asynchronous. Now we're going to talk a little bit more about that and what that means, but just know that state can be modified using this .set state. So there's a right way to update. There's a right way to update the state, and there's a wrong way, and we'll get into that. Then the right way is using this .state. So component state. So what is state exactly? So state is a JavaScript object that stores the component's dynamic data and determines the component's behavior. So when we have that instance of a class, there is a concept of behavior of that class, right? When certain things change in that class, in that instance, that's kind of a change in its behavior, right? So the UI needs to reflect that. If something has changed, it needs to maybe redraw something. In the example we're going to give, we have a concept of a clock, a ticking clock, and on every second it ticks, the DOM element that is displaying the time needs to be updated. And if you remember from our previous example when we showed this, we had a HTML input with a timer, and we had a React version of it, and we noticed in the DOM when it was reconciling that only that node that held the display of the time was the node that was updating, versus the HTML element with a set timer was tearing down the tree every single time. So it's when state changes, it triggers the DOM to redo that tree reconciliation, and it's very dynamic. So that's what we're talking about when we're tracking the dynamic information between renders. That's what that statement is talking about. And again, it can only be used by a class component, and it's private to component because class is encapsulated, right? Um, there's private, public, and protected, if you remember. And I think I think I remember this a long time ago. It was quite funny. It was like, um, your public stuff is available to everybody. Your protected items are for your friends, and your privates are for yourself, right? So that's the way that you can remember. You can remember all those things for class components, and state is private to the component, and nobody else should be touching that. So state is similar to props, but unlike prop, state can change, as we said. So if we're looking at that, we can visualize that state is internal to this component here, and we pass in props from the outside. They come into the component, and it renders out to the DOM. So state is immutable. We said it's read-only. It cannot change. It should never be altered directly, and changes should be made to the copy of the current version of state. So we want to modify the copied version, and we want to make changes to that copy and then update the state, just like how we are using the virtual DOM to make changes to the virtual DOM, and then it updates the real DOM. Same concept applies here. So the benefits, such as improving the ability to review state at different points in time for apps to hot reload. So when we look at Redux, Redux is a tool for state memory and tracking state changes. They actually have a very interesting feature in that allows for time travel. So what time travel means is you can actually go back in time in your debugging, and you can play a little bit of a history to see exactly all of the state changes that may have occurred during, say, part of your application running. And it's actually pretty neat, and it's a good way to kind of track errors that maybe 10 seconds ago the state was different than it was after that period of time, and you can see in the middle of that interval maybe what has happened internally to the component, and it's quite a neat feature. So it allows for tracking of this kind of thing. So when we mention hot reload, basically what that means is the automatic reloading of the page in the browser when you make a code change, right? So adding state. So we're going to use this clock component example. So the clock component, if you look at the code on the left here, so what's wrong with this code is we have a functional component. So function clock, and we have the props up here. So we have this functional component, and it's camel casing the front's the clock, and it has this prop. So we're going to pass something into the props. And if you remember from previously, props only goes in one direction, and it goes down. So props get passed from the parent component all the way down to the children, or however many descendants it may have, but props never go back up, right? You need to use another mechanism, which we're going to talk about, which is events, to trigger that back up to the parent. Otherwise, you may use a hook, but we're not there yet, right? So in this scenario here, we have a functional component named clock that returns a piece of JSX that says hello world, and it says it is props.date, and it converts it to local time. And pretty much what's happening is it's called by a parent functional component that calls React DOM.render, and inside of that it has our clock component here, and as a prop it's passing in the current date, and it's rendering that. So if you just had that and you called tick, it would just display the current date and stop. But in order to orchestrate a clock, we have to, outside of all of this, down here have the set interval JavaScript function that on every second interval we'll call the tick method, which then will render and call the clock component. passing in the current date. So we're kind of orchestrating things from the outside, which ideally this clock component should do everything itself. But we need to add state to do that. So we need to convert this a little bit. So in order to convert a function to a class, we would have to go the ES6 class route, and we have to go through and we have to remove the function call, the function syntax, and so put class clock extends from React.component. And then once we extend from that base component, we automatically get the render method right here that comes along with it, along with a lot of other things like state, set state, all these things. We also have, and we'll talk about a little bit in later slides, we have a whole bunch of lifecycle methods we can also hook into. So we add that render method and we move all that JSX from the functional component inside of there, and we have to replace props with this dot props inside the render by. So as you know, when we're talking about classes and instances, it has a concept of this. And what does this stand for? This means this instance, right? Internally, it means that this instance of the class, not. So if you may have multiple instances of a clock component, you may have 3 or 4 or 5, but when you're referring to this, it means one clock component internally, this instance. So you may have 6 components, each of them have a distinct this instance inside of them because they're encapsulated and they know about their own selves, their own private properties internally. They know they can keep track of their own attributes and state, right? So that's what that means. So adding local state to a class. So what we need to do is we need to replace this dot props with state in the render method. And when we have a class, we need to have the class constructor. So when we are talking about the class constructor, a good pattern is always call this constructor with props. And then we call super, which is the base class in React.component. It will have a constructor itself. And it's best practice to always, in your class constructor, to call the base class constructor and pass in the props. So this is the way we need to construct this. And inside of here, we're initializing this dot state, and we're adding something called date, and we're defaulting it to the current time. And we actually remove the date from clock here. So we're actually remove that. So if we just ran this right now, if you notice, we remove the call to set interval. So right now, and I'll show it in a demo after this video, is that when you were to run this right now, it's gonna create an instance of this class component, sorry, the clock component, and it's gonna render the current time and it's gonna stop because there's no mechanism right now to trigger the DOM tree to trigger React virtual DOM and the DOM tree to update anything. It's just going to create one instance of itself, and then it's going to render, and that's it. It's going to be a static clock, so it's not really much good to what we want to do. But this is the first step to getting there. We're initializing local state in the class. So to get there, we need to use something called the set state method. So because we have extended from React.component, we'll inherit this set state method, right? It doesn't come out of thin air, and it's not magic, right? You may think it's magic, like it just works, but if you understand inheritance, all this stuff is coming as part of the markup of that super component, that base component. So set state is available to you. Now you might have to read the documentation to figure out what it needs. If you just see it somewhere and you copy, you don't know what it does. You have to actually read up on it and know where it's coming from, right? It's not part of the ES6 language. So to use it correctly, we don't want to modify state directly. We want to use the set state method to modify state, and we'll tell you why. When you call this .set state from when you're in your class, the object will be copied onto this state, but it won't change immediately. So we're going to get into how it takes the previous state, adds to it, and then uses that as a current state, right? It's actually going to keep track of what you previously had and the new changes, and it's going to merge it. And then that merged state will be the new state. That's why you use set state. And you don't actually do it. This way on the right, on the left here, to modify this.state.comment equal hello, you don't want to do that because you've basically overwritten the previous state with your current state, if that makes any sense. The right way to do it is to go through this function called this.state because it's going to do the merging for you and it's going to do that reconciliation of state for you. So when we actually trigger that update, React will be smart enough to re-render the component and all its nested components. It's going to go through all that tree reconciliation with the virtual DOM. It's going to be smart enough that if you have a clock ticking somewhere way down in the tree, it's only going to update that node or that branch that has that component, clock component on it. It's not going to tear down that whole tree. It's going to be smart enough to trigger. If in fact you had two clocks on the two kind of timers going on, it'll be smart enough to update only those two branches of the tree. And again, not tear down the entire thing. So again, it's asynchronous. Reconciliation, we keep using that word, the process of re-rendering that component tree. You're going to get used to that, tree reconciliation. In fact, that's actually a good question to test on. And it's asynchronous, which means multiple calls can be happening to set state, and it's going to try to batch everything in one call, right? So it may be waiting for a bunch of calls, and then update the tree at a certain amount of time. That's why sometimes you don't see the new values right away when you update it. You'll have to get into certain situations about that, but just keep that in mind sometimes. Maybe when you're using Axios and you're trying to grab data from the backend, sometimes it's not going to happen right away, but it will happen a second later or something like that. So on the left here, we have the wrong way to set state. So don't rely on this.state and this.props because they may be updated asynchronously. So the right way to do it is, if you can see this, is using this.state, and this should really be called previous state. So it's set state will receive the previous state and the props at the time of the update. So it's going to do that reconciliation where it's taking the previous state counter and the current prop increment, and it's going to do the merging for you. Whereas opposed over here is you're actually not using the previous state. You're using the current state with the props. So you may get a problem there with, you may get your state in a bad state. You may get some corrupted state values. That's why you rely on this.state. You call that function and you use previous state. It'll be smart enough to know how to reconcile that. So we were talking about what state does and how set state merges the new state with the old state. All the previous state remains unless it's overwritten. So if you look on this on the left side, previous state A1 and B2, that's the previous state, plus the new state change. We do this dot set state. So B becomes 3 and C becomes 4, and now the new state is A1, B3, and C4. So it hadn't overwritten completely the previous state. Just in the other example, we were actually going to overwrite it by not using set state in the right way. So we need to use it in the right way so that set state will merge everything for us. Unless you overwrite it, it'll keep some of that stuff around until you go and clear it out yourself. So we talked about React hooks, and React hooks are a new addition in React 16.8, and they let you use state and other features without writing a class. So to be honest, I wasn't a very big fan of React until I saw this. I was from the Angular camp and TypeScript and all of that kind of strong typing and classes and things like that. And I kind of thought React was a little bit rudimentary, to be honest, because you had to do a lot of prop drilling, which is if you have a big component tree, you have to really drill down the props and keep passing stuff all the way down. And then you have to use events to pass stuff all the way up. And then you have to use class components. And to be honest, I didn't like it too much. But when we get into hooks in a couple of the classes and we start using them, you'll see why they're powerful, because you can walk up to that functional component and you can give it state, which you couldn't do before, right? So don't use this right now. It's kind of cheating, but it's kind of looking ahead. But you basically can use this thing called useState from React, and you can automatically give some type of state mechanism to your older functional components. And you can actually do things with that. And you couldn't normally do that before. So it lets you hook into state, and it lets you do some really, really cool stuff with it. And there's a bunch of other hooks there that actually are very useful throughout the whole application. And because of them, I actually am very pro React these days. So we'll get into those in later modules. But for now, we're actually going to look at improving that clock component we're trying to do. We're trying to make it tick by itself. And in order to do that, we need to use something called component lifecycle. So like lifecycle means, when you actually extend from that React component, you have a whole bunch of lifecycle methods that you can actually override or use. If you need, you can override them and tie into them, right? Hook into the different operations that happen in a component's lifecycle. When it has been created or immediate after, or when it has been inserted from the DOM tree or it has been taken out of the DOM tree, there's all events that you can hook into and add all of your own logic in there. So on the left, there's something like a first render. It goes through what happens, and then the initial state of it, component will mount, render, component did mount. So if you know anything about ASP.NET and web forms, if you ever came from there, my God, do they have a huge life cycle. And it is a lot of stuff happens along the way. And thank God React's life cycle is not like that, because you had about 10 to at least 10 different type of life cycle methods that happened, on render, pre-render, on load, on unload, on create, on destroy, on init, all these different things, right? Here it's a much more simpler one. But again, you need life cycle to tie in some things, but thankfully, we're only going to need a few of them for this example, and you start to use the same ones over time, right? So they're really useful for implementing a wrap component to wrap in an API. So this is a kind of interesting example I saw. I just wanted to include it. Like, if you could actually create a React component and use it inside of a jQuery plugin, but you would have to tie into the lifecycle method to initialize the jQuery plugin, if that makes any sense. And this is something you can't do with Angular 2, right? You couldn't put Angular 2 component inside of a jQuery plugin because it's a framework, right? And you can't stick a framework inside of a jQuery plugin. I mean, maybe you could, but it would be extremely painful to do, and it would be. Correct me if I'm wrong. If somebody does it, please let me know. But I'm sure there's a lot of headache to it. Whereas with React, you just include the reference, and it's all JavaScript, and you can actually you're off to the races, right? You have some really good integration that you can do with other libraries and other plugins. So you could do that. So quickly looking at the component lifecycle, we have an initialization period that happens on the left here. And we have, so in the initialization period, props are set. Initial state of that component happens in the constructor. Then when this component is mounted in the DOM tree, we have an event right here called component will mount. So if you actually see it, it always starts with a component and then the rest is camel case. And then the render happens. So the render is right before the component is visible. And then after it mounts and it is visible, we have a lifecycle method called component did mount. So component will mount and did mount, you'll actually tie into a lot. And then there's something called update. So props and for set state, there's something called component will update. And then when it updates, it renders, and then it says it did update. So when state is about to change, when it renders, and when state did change. And then finally, when we're going to leave this component, we have something called unmount. So when the component will unmount, meaning maybe you routed away and that component now has been taken out of the DOM tree, you can trigger some things to happen in there. Maybe you need to clean up some stuff. Maybe you need to close some connections because now your component is kind of destroyed. A class is kind of being destroyed, or it's basically taken out of the DOM tree. You can do some cleanup in there. So if we're looking back at our clock example, so we want this clock to tick by itself, right? We want it to internally call itself. So we made some changes here. We removed the function call for tick. I'm sorry about this little menu bar popping up, but in this left side here, we basically took the function call that was wrapped around it and it was called externally. So now it's just a react.render, and it looks at that clock component and it puts it into the root element. And from then on, a clock component will initialize itself with the set state and the current date. and then it's going to trigger itself. It's just going to keep triggering itself every second. So how it's going to do that is when it walks up, when it mounts, component did mount, it's going to create a timer, and that set interval is going to kick off that set interval at every second, and it's going to call this dot tick. And this dot tick every second will make a reference, will actually call this dot set state, and it's going to update the date, which is the current date, with new date, which is the current date. So every second it's going to tick, it's going to create, it's going to set the state to the current date and time, and it's just going to keep doing that and trigger itself for every second. So component did mount did the setup, and by reference it's going to have that callback called this.tick that's going to update state, and then it's going to re-render. React's going to be smart enough to re-render that node to update the time, and it's going to call this JSX piece, and it's going to actually display this .state to local time string. So it's going to re-render, call that, take a look at the state value at the time, and render that JSX, and then the next tick is going to go through the same thing. It's going to update state, therefore it's going to call render, render is going to call this .set state, and then it's going to display, and then it's going to keep going in that loop. When this component is unmounted, which means it's going to be removed from the DOM, React is going to call component will unmount lifecycle method, which is right here, and then we're going to clear that timer out because there's no point in having that timer keep going. And behind the scene, we need to actually stop it. So that's how we took a functional component clock and turned it into a class component, and we gave it some lifecycle methods, and we gave it some state so that it triggered itself internally.